Welcome to the Day 2 Notes, which is a continuation of Section 8.2. Yesterday we started 8.2 with compound interest, and then with modeling exponential growth and decay. Today we're going to move on. First, we are going to solve exponential equations by getting the same base, and then we are also going to model a situation using exponential growth or decay. And that's what we started yesterday. So there's one main golden rule for these notes. The golden rule says b to the x equals b to the y if and only if x equals y. So all this is saying is if you have the base is the same, so the b is the same, the exponents have to be the same. So if you look at example 1, we have 2 to the power of 3x, 2 to the power of 4. Because 2 is equal to 2, my exponents are going to be equal. So I would do 3x equals 4, and I get x equals 4/3. Of course, as you can probably guess, each example is not going to be this easy. Oftentimes, we're going to give you something like example 2, where the bases are not the same. So in example 2, I have 2 to the power x equals 8 to the third. Well, 2 and 8 are not the same, so I can't just set my exponents equal. I can't do, oh great, x equals 3. No. Instead, I have to reevaluate both of them. Now 2 to the power x, that can't be simplified at all. There's no way to rewrite 2. So 2 is just going to stay 2 to the x. I need to think, is there some way to rewrite 8 to the third? Well, if I remember, 8 is 4 times 2, 4 is 2 times 2. So 8 is really 2 to the third power. Okay, so I had 8 to the third. Now instead of 8, though, I'm going to write 2 to the third, and then that third power stays. Sorry, I dropped my equal sign. So now on my left side, I have 2 to the x. On the right side, 3 multiplies by 3, and the exponent becomes 9. So 2 to the x equals 2 to the 9th. Now I have 2 equals 2, so I can set my exponents equal, and I get x equals 9. Okay, so to say again what we just did, all we did was rewrite 8. We rewrote 8 as 2 to the third. And then this 3 comes from the exponent that was already outside. And then I solved. I would like you to pause the video and try example 3 on your own. I will tell you, you cannot simplify 3 to the power 6x. Instead, you're going to have to rewrite that 9. Pause the video and try this one on your own, please. Good luck. Okay, let's see how we did. I already told you that you cannot simplify the right side. So 3 to the 6x stays like that. Hopefully you figured out that 9 is 3 squared. And then you keep that exponent 2x minus 1. Simplifying on the left side, I can multiply the exponents. So this is 3 to the power 2 multiplied by 2x minus 1. On the right side, it's 3 to the 6x. Now, my bases are the same. I have 3 and 3, so I can set the exponents equal. So I have 2 multiplied by 2x minus 1 is equal to 6x. If I distribute that 2, I get 4x minus 2 equals 6x. If I subtract 4x, I get negative 2 equals 2x, and x equals negative 1. Hopefully you got that one right. The key was remembering or figuring out that 9 is 3 to the second power, 3 squared. So if you did that, it was probably smooth sailing. If you missed it, that was okay. We are going to do a few more examples. Okay, so moving on. Now with examples 2 and 3, we only changed one side of the equation. With examples 4 and 5, we're going to have to change both sides. Looking at example 4, I have 1/2 to the power x, and I have 4 to the power 3x. I'm going to start by changing that right side. 4 is pretty logical to change because we know that 4 is 2 squared. So I have 1/2 to the power x equals, now 4 is 2 squared, and that's to the 3x power. So this becomes 1/2 to the x power equals 2. Multiplying my exponents, I get 2 to the 6x. Now the issue is that the bases are not the same on the left and right side. I have 1/2 and I have 2. Those are not the same, so I can't set my exponents equal. Instead, I have to figure out some way to make them equal. Well, is there any way to write 1/2? Rewrite 1/2, that is. Well, 1/2 is 2 to the negative first power. Multiplying exponents, this becomes 2 to the negative x equals 2 to the 6x. Now my bases are the same. I have 2 on the left side, 2 on the right side. So I can set my exponents equal. I have negative x equals 6x. If I add that negative x to the right side, I have 0 equals 7x, and x equals 0. So if I were to substitute in 0, both sides of the equation would be the same. Okay, you pause the video and try example 5 on your own, please. This is similar to example 4 in that you're going to have to change both sides of the equation. Good luck. Okay, let's see how we did. I'm going to start by rewriting the right side. 27 is 3 to the third. 1 over 9 is going to be 3 to the negative second. 3 squared would be 9, so 3 to the negative second is going to be 1 over 9. The left side becomes 3 to the power negative 4x. The right side becomes 3 to the 12th. I have 3 as both bases, so I can set my exponents equal. I have negative 4x equals 12. Dividing by negative 4, I get x equals negative 3. Hopefully you got that one right. If you didn't, hopefully it was just a tiny mistake that you made. Next, we're going to flip to the next page, and we're going to do some more modeling with exponential growth and decay. Okay, we're going to do some word problems. You will need a calculator. I'm going to ask you, though, to skip 6 and 7 for right now. We're going to start with 8 and 9. So we're going to start with 8 and 9 and then go back to 6 and 7. So 8 and 9 says, write an exponential function for the graph that passes through the given points. So the general form of an exponential function is y equals a multiplied by b to the x. Okay, so x and y are going to stay there because this is an equation. A and b are what we need to substitute for. We are given 2 points that we can use to find a and b. I'm going to substitute in my first point, 0, 125. Remember that this, is x, y. So I have 125 equals a times b to the 0 power. Remember that b to the 0 power is 1, so that just goes away. So I got a equals 125. So far I have y equals 125 times b to the x. Now I need to find out what b is. That's where my second point comes in. Again, I'm going to substitute for x and y. This time I have 1,000 equals 125 times b to the third. If I divide both sides by 125, I get 8 equals b to the third. Now I just need to get rid of that third power. Hopefully you remember from last chapter that to get rid of that third power, I can take everything to the 1/3 power. So I have 8 to the 1/3 power equals b. You can use a calculator to do this, 8 caret, and then the 1/3 power in parentheses, and I get b to be 2. And now I can write this back in my equation again. Now my equation becomes y equals 125 times 2 to the x. And that's it. So again, the first point is going to be 0, some number. You're going to substitute that in, and that should give you a. The next point will help you find b. So right now, pause the video and try example 9 on your own, please. Good luck. Okay, let's see how we did. So we're going to start with y equals a times b to the x. My first point is x comma y. So I have 144 equals a times b to the 0. B to the 0 is just 1, so I have a equals 144. Now my equation is y equals 144 times b to the x. That's where my next point comes in. It's going to be substituted for x and y. So I have 21,609 is equal to 144 times b to the 4th power. I have to divide everything by 144. When I do that, I get b to the 4th equals 150.0625. Now I just need to get rid of that 4th power. To get rid of the 4th power, I take the reciprocal power, the 1/4 power. When I take 150.0625 to the 1/4 power, I get b to be 3.5. So my final equation is y equals 144 multiplied by 3.5 to the x power. Hopefully you got that one right. If not, we're going to use this skill in the word problem, so you're going to get a little more practice. One thing to note is please do not simplify this 144 multiplied by 3.5 or the 125 multiplied by 2. Do not combine those. The x power is only applies to the 3.5. It doesn't apply to the 144, which is why you cannot combine them. Okay, now we're going to need to use this idea of writing equations for the two word problems. So let's go back to example 6. Okay, so this example starts, Kristen starts an experiment with 7,500 bacteria cells. After 4 hours, there are 23,000 cells. Write an exponential function that could be used to model the number of bacteria after x hours. Okay, so we need to write an exponential function. So this is what we just did. It says she starts the experiment with 7,500 cells. So when time is 0, she has 7,500 cells. It says after 4 hours, there are 23,000 cells. So after 4 hours, there are 23,000 cells. Okay, now this is exactly the same information we had before, so we can write an equation. We're going to start with y equals a times b to the x. Substituting in my first point, I have 7,500 equals a times b to the 0. B to the 0 is just 1, so I get a equals 7,500. Okay, so now I need to substitute in my second point. 4 will be substituted for x, 23,000 will be substituted for y. So I have 23,000 equals 7,500 times b to the x. B to the 4th. When I divide by 7,500, I get b to the 4th equals 3.067. Now to get rid of that 4th power, I have to take everything to the 1/4 power instead. When I take 3.067 to the 1/4 power, I get b to be 1.32. So my final function becomes y equals 7,500 multiplied by 1.32 to the x power. In this case, y is the number of cells, and then x is the number of hours. So now that we wrote the equation, we're going to use it. It says how many bacteria cells can be expected in the sample after 12 hours. So that 12 hours is telling us that x equals 12. So now I'm going to do y equals 7,500 multiplied by 1.32 to the 12th power. When I do that, I get about 209,869.07 cells. So after only 12 hours, we're going to go from 7,500 cells to 209,869. It's kind of a huge jump. Okay, so let's move on to word problem number 7, or example number 7. Again, there's a stop sign, which means this is one that you're doing on your own. So if you would take a few minutes, pause the video, and try this one on your own, please. As a hint, in the word problem it says, a manufacturer distributed 3.2 million aluminum cans in 2005. In 2010, the manufacturer distributed 420,000 cans, blah, blah, blah. So you're given 3.2 million and 420,000. Don't use the number 3.2 in your equation. 3.2 million looks like that. So make sure you use that number instead of 3.2 in your equation. Good luck. Now, I'm assuming that you had a chance to try this one on your own. The first answer should be y equals 3.2 million multiplied by 0.67 to the x power. Using that for example B, or for the second part of the example, you should have gotten the answer to be 0.048 cans. If you didn't get those answers, please make sure you go back and find your mistake. If you got the equation in the first part wrong, you're going to get the second part wrong automatically. Please find your mistakes, and if you have any questions, bring them to class tomorrow. Goodbye.